Um, so some things that we want to note in regards of solving these rational equations. Your first goal here, when solving them, I would suggest first, uh, you know, to factor your denominators. Then find your LTD. Then multiply each fraction by what it's missing in order for it to look like the LTD. After that, step 3, all denominators should be the same. And when they're all the same, you can cancel them. And now from there, you just solve. So a nice 5-step process on solving these rational equations. Does anyone need another minute writing this down? All right, let's take a look at some examples. First example, we want to solve 2 over 3 minus 5 over 6 equals 1 over x. So if we take a look here, let's follow the same steps. It said first the factor. Well, we can't do anything for the first one. 6 is just 2 over 3. And then there we have 1 over x. All right, so it's like we prime factorized that 6 to be 2 times 3. It looks like your LTD here is just 2 times 3 times x. Right? Because remember, the LTD are the different factors. Any questions there, y'all? Any questions? Okay. So now we multiply each part by what it's missing in order to look like the LTD. So it looks like the first one is missing a 2 and an x. The middle one is missing an x. Last one is missing a 2 and 3. Any questions there? Now you should notice that all the denominators are the same, and when they all look the same, you can just cancel them all off. Right? So we're just left now with 4x minus 5x equals 6. And now we just solve this equation, a really nice equation. It's negative 1x equals 6. Then after we divide each side by negative 1, we get x to equal negative 6. So any questions with that first example? Anyone need another minute copying this down?
Yes, please.
All right, just let me know when you're done. Yeah, done copying it there?
Yes, sir.
All right. Next example here. We have 2x over x minus 3 minus 6x equals 18 over x squared minus 3x. So 2x over x minus 3 minus 6 over x equals 18 over x squared minus 3x. So let's factor. You should notice that you should be able to factor the last fraction. Pull out an x, leaving us with x minus 3. Looks like your LCD here is just an x and the x minus 3. So now we're going to multiply each one by whatever it's missing in order to look like this LCD. All right. So 2x over x minus 3. Looks like we're going to multiply that by x times x times x. This 6x looks like we're multiplying that by x minus 3. And then this 18 over x times x minus 3 doesn't look like we have to multiply over it by anything. So any questions on that part right there? Now we're just multiplying it by whatever it's missing, right, in order to look like that LCD. Since all the denominators are now the same, we can go ahead and cancel all them out. Just working with the top part now, it looks like we have 2x squared, right, minus 6, open parentheses, x minus 3 equals 18. Any questions there? Any questions there? And now this negative 6, right? We distribute to both of those terms, leaving us with 2x squared minus 6x plus 18 equals 18. Because of the power 2, it's quadratic, so we want to set it equal to 0. Right, so I'm going to subtract this 18, and notice that what happens there, both of those are gone. All right, we're left with 2x squared minus 6x equals 0. And we should be able to solve this here. All right, looks like this has a GCF with 2x, right? So we pull out a 2x, leaving us with x minus 3 equals 0. And then from there, we solve each one. That's a little review from 4.8, if I'm not mistaken. All right, divide by 2, divide by 2. We get x equals 0. And we add 3, we add 3. We get x to equal 3. So any questions there? Any questions there? Okay, but before we claim a solution, we want to check our work. If you check your work, notice that 3 will not work. All right, I mean, I think actually both of these will not work. All right, we check our answer, right? We have 2x over, let's go with 0. And we have 2 times 0 over 0 minus 3. Minus 6 over 0 equals 18 over 0 squared minus 3 times 0. Notice that this causes an error. So 0 is not a solution. You can't have 0 in the bottom. And if we do the x equaling 3, 2 times 3, 3 minus 3, minus 6 over 3 equals 18 over 3 squared minus 3 times 3. Notice that this here causes an error. So because of that, both of those are wrong. Here we get no solution. Any questions with this example? Any questions?
I don't have a question on this one, but I was just wondering, on the review, those questions are the questions on the test, right? Just
correct.
Okay.
Very good. Very good. And also, let me elaborate a little bit on that. I think Renee has a good point and a great question. This problem here covers 4.4, or it covers 4.6, factoring with special techniques. It covers 4.8, solving an equation by factoring. It also covers 4.2, multiplying polynomials. What else does it cover? We're subtracting rational expressions. If I'm not mistaken, I think that's, what was that, 5.2? 5.2. And then obviously it covers this section, which is 5.4. This problem covers all of that. Okay? This problem covers all of that. So let me note these really quickly, and let me talk about something. 4.6, 4.8, 4.2, 5.2, 5.4. I'm going to go away from this problem here for a minute, okay? So let me stop this sharing. Let me share this test to review. Okay. So I just talked about how that problem covers 4, 2, 4, 6, 4, 8, 5, 2, and 5, 4. And if you look at these problems, for example, question number 1 is a 4.1 problem. Question number 2 is a 4.1. Question number 3 is a 4.1. Question number 4 is a 4.1. Then we have more 4.1s. All of a sudden, we have some 4.2s. Right? We have some 4.2s. Looks like 6 through 6. Number 6 through 13 is 4.2. There's a good chance none of those will be on the test. I'm not going to put any of those on the test. Because why put those on the test when I can put that problem that has that? That covers that. Does that make sense? 4.6, I probably won't put any of those. Looking here, 4.6, wherever they may be. I may not cover any of those. I would think, looking at this review, let's just take a quick glance at it. Stop sharing. Let me share again. Right? I mean, I don't think I'm going to put this. Why put that on the test if I can put another problem that's going to have that? Why put that on the test if I can put another problem that's going to have it? Why put that on the test if I'm going to put another problem that has it? All of these problems that I'm looking at right now, none of these will probably be test problems. These are all, there's no point on putting those those on the test. Like all of these, I don't think, and maybe that one, maybe, because that's a that's knowing difference of cubes. But a lot of these, I mean, they're on there for you to practice. Because in order for you to be able to do anything in chapter 5, now that is a test problem because that covers 2 previous problems. Now that is a test problem. That is a test problem. And even if we go back, I probably won't put that one on. That one I'd probably even say no because that's one fraction where I'm better off putting on something like that that has the previous problem on there. You should expect the problems on your test to have 2 fractions or more. That's a good one. 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 Right? That's a good one too, because that's dividing, right? Right? Even that one too, because you need to know how to do that. Right? So when you're looking at these, you should really be focusing. That's a good one too, because that has a lot of factoring on it. So I'd probably pick that one over some of those other ones from 5.1. So when you're preparing for your test, the first half is just to remind you on your review, right? On the review, let's stop. I want to share this. The first half of the problems, let's see how far. I would say you really want to know how to do $40 and up. That's really what your test is going to be on. All of this is going to be found in every one of those problems. Does that make sense, everybody? Does anyone have questions about that? You need to master 40 through 60. If you can do 40 through 60, you can do 1 through 30 because 1 through 30 are easy problems. 40 through 60 is what you need to understand. Right? You can do 40 through 60, 1 through 39 are going to be a mistake. Right. So thank you for bringing up that comment. Really these problems, 40 through 60 is what you should expect your test to look. Right. That's 20 problems. I think that's a good amount for I'm testing. All right. So good. I want to mention that. Thank you for that question as well. All right. So back to our material. Let's take a look at our next example. X squared over x minus 2 equals 4 over x minus 2. So this is a nice one. I mean, both of these denominators are already the same. So that's great, right? When they're the same, you can just cancel them out. And I'll do that on the next step here. Let me rewrite this. Right? Because remember the whole goal, we want the denominators to be the same. They're the same, cancel them. Right? So we're just working with x squared equals 4. Right? Should be able to solve this here. Right? All we really have to do with this is set it equal to 0, right? Subtract 4, get x squared minus 4 equals 0. And it should be a nice problem there to factor, right? Do your difference of squares there. All right, so you should get x minus 2, x plus 2 equals 0. Solving each one, that gives us an answer of 2 and gives us an answer of negative 2. Any questions there? You'll notice that one of these will not be an answer, though. Right? If you go to check your work, right, with the 2, you got 2 squared over 2 minus 2 equals 4 over 2 minus 2. Notice that both of these bottoms give errors, right? Because you can't have 0 on the bottom, taking that off. But it won't do that to your negative 2. So this will only give us one answer. That answer will be negative 2. Any questions with that example? Does anyone need another minute copying that down? All right. Next one here. We have 2 over x minus 1 equals 3 over x plus 1. A nice example, we don't have to factor here, right? But we do want to find LTD. Right? LTD would just be x minus 1, x plus 1. Right, so we're multiplying the first fraction by something and the second fraction by something because we want both denominators to be their LTD. Right, so it looks like the first one will be by x plus 1. The second one will be by x minus 1. And now that the denominators are the same, you can cancel them all out. All right, leaving us with 2 open parentheses, x plus 1 equals 3 open parentheses, x minus 1. And we distribute and solve. So we had 2x plus 2 equals 3x minus 3. And we just kind of continue minus 2x cancels 2 equals x minus 3. And then our last step then would be just to add 3 to both sides. Right? And it looks like that answer should work out because if you put it in the denominators, you do not get error. Any questions with this example, y'all? Any questions? Anyone need another minute copying this down? All right. And it looks like we just got one more example here. We have 2 over x plus 5 plus 1 over x minus 5. 5 there. Equals 16 over x squared minus 25. So we factor. You should notice that the last one is just the first 2 fractions. Right? The denominator, the first 2 fractions. You should also notice that that's the LTD. All right, so we should be multiplying the first one by x minus 5. Multiplying the next one by x plus 5. And the last one by nothing at all. Any questions there, y'all? Any questions? All right, denominators are all the same. Cancel them all out. Right, leaves us with 2 open parentheses x minus 5 plus 1 open parentheses x plus 5 equals 16. And now it doesn't look too bad. Right? We just solve that. We distribute. All right, distribute, combine some like terms. What do you get? 2x minus 10 plus 1x plus 5 equals 16. Should be able to combine those. Combine those. It looks like a 3x minus 5 equals 16. And then we just solve for x. Right, adding 5 to both sides. And I show every step. I mean, you don't have to show every single step when it comes to solving this equation, but it never hurts, right? Sometimes students forget on how to do those steps. So we get an answer of 7.